Today's lesson is Spiral Lesson 1. It should be page 34 in your notebook. We're going to skip a couple pages. And we're going to talk about domain of rational functions today. And our goal today is to be able to identify all of the possible inputs for a rational function. And so this is something a little bit new, because finding domain when you're given an equation means that you're trying to figure out what values can you plug into the function that result in some output value. And there's certain limitations that we're going to learn about, and one of those limitations is when we have rational functions. So let's go ahead and define what a rational function is. So a rational function is a function that is a fraction. So it's functions that look like f of x equals 2 plus x over x minus 1. So it's when you have a function that has a denominator and a numerator, just like this one does. Or another example would be f of x equals 5 divided by 2x. So these are examples of rational functions, ratios. Domain is the set of all of x values that have a y value, and we'll learn in this lesson that there are certain x values that do not have a y value for rational functions. So the domain is all of the ones that do, and we're going to list the domain in set notation. So set notation is where you say, okay, the domain is all these x values, and then this would be like x can be any number, all real numbers. You would say x is all real numbers. So that means x can be any number you can think of, and there'll be some y value you get after you plug it in, after you evaluate and plug it in. Division by 0, and this is the limitation for rational functions. So this is a limitation. And what this looks like is when you have 0 in the denominator. So let's say that you've got this function f of x equals 5 over x, and you are evaluating f of 0, so that means you're going to put 0 in for x, which equals 5 over 0. So 5 divided by 0, where you have 0 in the denominator, equals undefined. So anytime you get undefined with a rational function, that's a number that is not part of your domain. So in this case, if I wrote the domain for this function, 0 gives me, when I plug in 0 for x, I get 0 in the denominator. So my domain would be x can be all numbers. So we say x is all numbers, all reals, however, comma, x cannot equal 0 because that's a number that gives me undefined. And that's what we're doing today. We're figuring out the number that gives us an undefined value. So here we have example number 1. We've got our rational function with x minus 1 in the denominator. And so what we're trying to figure out is what number for x results in an undefined for y, or would result in a 0 in the denominator. Easy way to do that would be to take the denominator, so in this case x minus 1, and set it equal to 0. So that's our first step. Take the denominator and set it equal to 0. Solve would be our second step. So we get x equals 1. So 1 is the number that if we plugged in for x, 1 minus 1 would be 0. 1 gives us a 0, which is undefined. So our third step when we write the domain is to make sure that we identify that. So our domain is all x values, and x can be any real number. Except x cannot equal 1. So any other number except 1 we can plug into this function. Example number 2. So our first step is going to be to set the denominator equal to 0. And now we're going to solve for x. And we're going to say x cannot equal whatever this number simplifies to, and I'm going to use the calculator to simplify it. 7 divided by a negative 2.5. Negative 2.8. So our domain, x is all reals, except x cannot equal negative 2.8, and I can barely fit it. So here we have our denominator. We're going to set our denominator equal to 0. So we've got 5 equals 0. And you're wondering, where's the x value? So this is a case where you have a rational function where you do not have a variable in the denominator. So there's no x variable here. So there's no number that we plug in for x that would give us a 0 in the denominator. The denominator is always going to be 5. So our domain here would just be x can be all real numbers. There's no number that will give us an undefined value. So make sure there's an x value in the denominator before you go try solve some equation that doesn't have a variable in it. So x minus 2, we've got a variable in the numerator, variable in the denominator. We don't really care about the variable in the numerator because there's no limitations in the numerator. We're just focused on the denominator. What value for this variable would give us an undefined y value. So we're going to set it equal to 0. Solve. X cannot equal 2. So we go ahead and put that into our domain. Example number 5. So we've got a quadratic expression in the numerator, but variables in the numerator don't have limitations. At least this numerator. And we've got this variable in the denominator that does. So what value for x would result in a 0? We're going to set equal to 0. So we can say x cannot equal negative 3.6. That would be our domain. Any number but negative 3.6. And that is the last example for today. So hopefully this is enough examples for you to do well on the problem set. Good luck.